everybody. It is now 12:01 on my time, so we are going to go ahead and get started with today's presentation. My name is Kristen Bogdanis, and I am a nutrition and wellness educator with the University of Illinois Extension. And I am in the Henry, Mercer, Rock Island, and Stark counties, which is the northwest area of the state. And a lot of my programming revolves around food safety and food preservation with a special interest in fermentation. So I'm very excited to be able to moderate today's presentation. This series is a collaboration between Illinois Extension and the Interdisciplinary Health Sciences Institute at the University of Illinois, and is designed to connect those across the state with researchers at the university and provide evidence-based educational programming. Now, for a couple of housekeeping items before we begin, I would first like to launch a poll. This poll is to collect some of the basic information from our participants. And once you enter your information, feel free to minimize it off your screen. So here it comes. And secondly, if you are seeking CEUs or CPDUs, please click the link that I am going to put into the chat box here momentarily. So once you click that link, you're basically going to check in today's webinar. And you'll be receiving a follow-up email with an evaluation that needs to be filled out to finalize your CEU or CPDU process. For those of you calling in who would like CEUs, you can go to a web browser and type in go.illinois.edu/credits. If you have any questions during the program today, please type them into the chat box. And if you are calling in, please hold your questions until the end, and Breanna will get to them at that point in her presentation. Now, without further ado, I'd like to introduce our speaker for this series on fermented foods. Her name is Breanna Metras. She is a nutritional sciences PhD student at University of Illinois, Urbana-Champaign.
So thanks for the introduction, Kristen. Hi, everybody. Welcome to this talk. I'm really excited to talk to you guys. We're going to cover a lot of information, so get ready to go. So today's presentation is called Fermented Foods and What Do They Do? First, we'll do a little bit about me. 1 second. So that's my face. Hello. So currently I'm a second year PhD student, and I'm working towards getting my registered dietitian certificate as well at the University of Illinois in Urbana-Champaign. And I'm a part of the Division of Nutrition Sciences in Dr. Kelly Swanson's lab, where I investigate the microbiome, in specific how nutrition affects it, inflammation, and hopefully my thesis focus will be on phytochemicals. My projects so far for research have been the evaluation of commercial animal and human kefir products, and my current projects on the evaluation of citrus flavonoids in an ulcerative colitis mouse model for reducing inflammation in specifically the microbiome. And my background is that I'm from Boston, Massachusetts, where I did my BS in biochemistry and honors at the University of Massachusetts, Boston. And there I did participate in research, including organic chemistry, biochemistry, and food science research. And I was also a fine dining server in Boston for 4 years. So I've had a lot of exposures to different kinds of foods and different levels of food as well. So why am I qualified to talk about this? I am a biochemist by training, but I'm talking about fermented foods. So this is a picture of some aged Gouda, and then me with my really thick SCOBY from last year. I started brewing kombucha back in 2015, and through those years, I became obsessed with cheese and the process and where they come from and different areas of the world that produce different kinds of microbes. And I also did a short research project in my undergrad on the fermentation of sour beer and kind of compared it in its metabolism and how it forms to kombucha, which are very similar but different. And now currently in my house, I'm fermenting curry and soy sauce, some honey fermented garlic, honey fermented ginger, and honey fermented apples. And I also have a fridge stocked full of hot sauce and pickles at the moment. And a little bonus is my cat is named Kimchi, which is also a fermented food. And he might make an appearance. You just stay tuned. You might hear something going on in the background, hopefully not. So today we're gonna, like I said, we're covering a lot of information. So first we're gonna cover what is fermentation, the process. What is the difference between probiotics, fermented foods, and probiotic containing fermented foods? They're all different by definition. Then we're gonna talk about the gut microbiome a little bit in case anyone's not familiar. And then we're gonna talk about what the state of the research says today for those above types of food and what statements we can make and what we can't make based on research. And then we're gonna talk about how to read and break down a probiotic label. So the next time you go to the grocery store, hopefully you can understand it a lot better. And then we'll talk about at the end a bunch of different fermented foods you can make at home, how to do them, and what kind of bacteria and yeast you can expect to find if you do it right. So feel free to answer these next couple of questions in the chat. So go crazy. So what kind of fermented foods do you guys eat? Also, does anyone have any sourdough starters still going? And have you guys tried any fermented foods and had success, any failures? So I'll give the chat probably like 2 minutes. Just feel free to add some stuff to the chat. So we got a bunch of kombucha, sourdough starters. Oh, we got kimchi, pickles, and yogurt. Nice. Yeah, who doesn't love pickles, right? Yes, wine. Oh yeah, Marty's making beer. Okay. So lots of like the usual suspects. I like it. I like it. Oh yeah, Brian's made tempeh. Nice, nice. Coffee kombucha. Yeah, that's really cool. Never made that before, but I'm sure it'd be delicious. Yeah, I'll show you how to make not kimchi or kefir, but I'll give you links to some good websites where you can learn how to make those. 16-month-old mother. Yeah, that's really great. I think they get better with age. Okay, so we'll move on. All right, so first we're just going to cover a quick vocab, just some basic words that I'll be talking about. So just to clarify the definition, microorganism. So microbe, it's a microscopic organism which may exist in a single-celled form or a colony of cells. So that's just like the basic definition. The official definition of probiotic is a live microorganism that, when administered in adequate amounts, will confer a health benefit to the host. And that's a key part, is that it confers a health benefit. Fermented foods are defined as a food substrate, like a vegetable, dairy product, or even a meat product. And then there's added bacteria or yeast that are either naturally present or added to kickstart the fermentation process. And then we're gonna see later on CFU per gram. So that's colony forming units per gram. So that's basically how many live microorganisms are present in that fermented food per gram of that product. So that just shows you how many live probiotics or live microorganisms and not dead microorganisms in that product. So that'll be a little bit later. So this is another little participation for the group. If you guys want to add to the chat, some of these are easier, some of these are not. What are these to be fermented foods? That one's, see, anyone in the chat get these last ones? Oh, there's my cat. So we have grapes, and then those are cocoa beans. We also have hops. Yep, my cat is there. On the bottom left corner, those are some soybeans or edamame. Then we have some barley for beer brewing. And then does anyone have a guess for this last one that I just put up? I wonder if anyone can recognize it. Okay, yep, someone got it. It's coffee. So those are coffee berries. So the actual coffee bean is inside of that. And then we take it out, of course. So first we'll talk about what is the process of fermentation. So some of you guys might already know this, but we got to cover it. So this is a beautiful little chart. It has a lot of information, so don't let it get overwhelming or overwhelm you. So fermentation is defined as a oxygen-free metabolic process where an organism converts a carbohydrate like a starch or a sugar into alcohol or an acid. And today we'll be covering in detail ethanol fermentation and lactic acid fermentation because they're the most relevant to fermented foods. And another form of fermentation, which we'll not talk about, is the hydrogen and methane gas production. So as you can see, ethanol fermentation is usually with, we do a sugar plus yeast, and then that's how we get the process for wine and beer and other fermented beverages with ethanol in it. And then there's also commonly lactic acid fermentation, which uses aspergillus, lactobacillus, streptococcus bacteria to get common products that like cheddar cheese, yogurt, soy sauce, and the above. So if you ever want to come back to this presentation, reference this little table is really nice. So for ethanol fermentation, it's a process where yeast obtains energy by converting sugar into alcohol and carbon dioxide. So right below the definition, we have a really simple diagram. So we have the sucrose, so the sugar, the yeast cell consumes that sucrose for energy, and then its output is going to be carbon dioxide, so bubbles, and ethanol or alcohol. And then on the right side of the screen, I have a little diagram of some white grapes. And this is just the process of how ethanol fermentation can be used to produce different flavors. So for example, a wine company might have 3 different types of yeast strains. So that means that each of those yeast strains will digest the sucrose in a different way to produce different flavor compounds along with the carbon dioxide and ethanol. So you can see a wine 1, it might have lavender or pepper flavors. Wine 2 might have more citrus profile. And then the last one might have banana or pineapple flavor aromas. So that's just a little breakdown for, how ethanol fermentation can be manipulated to get different flavors. Okay, then we have lactic acid fermentation, which is what we'll probably be focusing on for the most part. And that's where bacteria converts carbohydrates into lactic acid. So in this really cute little bacteria, he's telling you about the process, and do not worry about the science behind it. It's not super important for this presentation, but if you're curious, you can see the glucose goes through the process of glycolysis, where it produces 2-pyruvate, which is an high energy compound. And then the pyruvate gets fermented by the bacteria to form lactate, and lactate is a form of acid. So in the background of this, we have fermented carrots, green beans, peppers, probably some sauerkraut, and those are all fermentations that go through the process of lactic acid fermentation. Okay. So now we're going to cover what is the difference between probiotics, fermented food, and probiotic containing fermented food, because I feel like a lot of people will kind of group them all together. And as we move forward in the research and making dietary recommendations and kind of solidifying what probiotics work and stuff like that, we need to also clarify these definitions. And as a consumer, I find like this will really help you too when you're at the store. So first we have the general overview of fermented foods. So these are just foods that undergo a process of fermentation. So a food or beverage made by extensive microbial growth. And depending on the food, the certain species of bacteria, yeast, or molds can carry out this process. And there's a variety of foods that contain live microorganisms. And be aware, there are lots and lots and lots of misinformation that people will tell you it's good for you, it's healthy for you, it makes you happier. I've seen everything under the sun, and a lot of that is misinformation that's not proved clinically. So just be very, very wary. And just another thing is fermented foods do not equal probiotics. And that's another thing you'll see at the store all the time. Like chocolate, which is a picture here, you have the cocoa beans and it gets fermented to chocolate, but you would never call chocolate a probiotic, right? So you have to be careful when you call things fermented foods and probiotics. They're both different. And so now we move on to like a subsection of fermented foods, and that's going to be fermented foods containing live cultures. Again, we need to see that these are all fermented foods in this picture, but they're commonly mislabeled as probiotics, but they're not. So these are typically found in the refrigerators at grocery stores. So they have to be kept cold to keep the living cultures alive, and they have active cultures. So you'll see active bubbles, you know, in the product if you shake it or if you really look at it closely. And some fermented foods that you'll commonly see in refrigerators at store are water or brine cured olives, usually in the deli section, so they're fresh. We have kefir, traditional salami, some cheeses, usually raw cheeses or non-pasteurized cheeses. So in the US, those are harder to find at a grocery store. Most yogurts that are, you know, in the refrigerator aisle, fresh sauerkraut. So we're talking about not necessarily the kind in the jar on the shelf, but we're talking about the sauerkraut you'll find in the fridge. Same goes for the sour dill pickles and fresh kimchi. So there's always going to be a difference between what you're going to find in the fridge section at stores and shelf stable fermented foods. Then we have another subsection, which is fermented foods that are consumed without living cultures. So they still go through the process of fermentation, but they're then pasteurized, baked, filtered, or there's preservatives added so that they don't contain live microorganisms at the point of purchase. But it also, you know, makes them a little bit safer. You know, the company selling it doesn't have to worry about something growing that they weren't gonna tell you about or you don't want to eat. So a lot of options for fermented foods without living cultures are tempeh, most soy sauces, most beer and wine that you find at the store, chocolate, cheeses, and sourdough bread. And this is a picture of one of my favorite cheeses, aged Gouda, with those calcium crystals and phosphate crystals in it. Absolutely delicious. Like I said, I'm a big fan of cheese. So now we're going to talk about what is the intestinal microflora or the microbiome, because this is my point of research and it's really relevant to this topic. So the microbiome is 100+ trillion bacteria that live in our colon, which, as you can see in this picture on the right, the colon is the very bottom part. And for modern sanitation, antibiotics, C-section births, formula feeding, all of these are, you know, outside actions that you can do that they will lead to a either malfunctioning microbiota or a slightly different you know, community that exists inside that microbiota. But don't worry, all of these microbiota is very changing and very flexible organ. So, you know, even if you did get formula fed or had a C-section, it's fine. You'll still be, your microbiota will even out, become more normal. And foods containing live microorganisms will or can reduce the risk for acute and chronic diseases. So, and they can also help maintain a healthy intestinal microbiome. So back to that slide with fermented foods containing live microorganisms, that's what we're talking about here. And we'll go into a little bit more detail on that little block in a couple minutes. And so just to focus back onto the right side of the screen, we have the beautiful image. And so this is a picture of your stomach, your liver, gallbladder, and then your large and small intestine. And as you can see in the stomach, there's only around 10 to the 2 or 10 to the 3, so a couple thousand bacteria in the stomach itself. And then as you move down, the majority of your bacteria for your gut microbiome is actually in the colon and the appendix. So you can see of 10 to the 9 up to 10 to the 12. So when people think about the microbiome, I feel like a lot of people think about the stomach. And the stomach, as you know, is very acidic. The pH is very low. So a lot of bacteria cannot survive there. So the reality is when you're having these fermented foods and even probiotics, you're really culturing your colon and your appendix the most. That's what you're really trying to make healthy, and you're trying to create a very diverse area. And I don't know if you guys were here for last week's talk, but Layla did talk about how to read a nutrition label, and she also talked about the gut microbiome in detail. So you can feel free to reference her talk if you have more questions, or you can ask at the end, that's fine. Oh, and then there's a nice little circle. So this is just a quick slide I put together just to clarify in case you guys are confused. So what we talked about, so we have food for thought. The blue block is prebiotics. Then we have fermented foods and probiotics. So these are the 3 categories that I'm not talking about prebiotics today, but I need to talk about it just as an inclusion for this diagram. So prebiotics are usually fibers, and they're food that your microbes inside your body will eat. Fermented foods are foods that you eat, and that can be subdivided into fermented foods retaining live cultures or fermented foods without live cultures. And then there's a third section, which is we'll talk about at the end too, which are fermented foods with added probiotic strains. So if you see like a yogurt, for example, with specifically bifidobacteria added, or this strain of lactobacillus, those are foods that kind of belong in this category. And then the third category, probiotics, which are just actual like supplements that you'll buy at the store, and it's a very specific strain, and it's usually recommended by your medical provider, and that's what specifically probiotics are. Okay. So one more definition time. So probiotics are live microorganisms that, when administered in adequate amounts, confer a health benefit on the host. And these are non-residential additions to our gut bacteria population. And these can exert effects on the microbiota as they travel throughout the GI tract. So they start, at the esophagus, and they'll travel down to your small intestine and colon, like we saw in the other picture. They use similar mechanisms like our native microbes to improve our health. So they're not, alien substrates. They do very similar processes as the microbes that currently exist in our body. So they're not brand new. And then probiotics can impact our gut microbiome indirectly. So other than culturing our body, they can also influence our immune system, and that will in turn influence our colonizing microbiota. And they have several other processes in which they can influence our whole body, which is really interesting. So the big question is, so after all this, are probiotics healthy for me, or are fermented foods healthy? Like, what's the deal with these guys? There's a lot of interesting facts, but what's important? So benefits to incorporating fermented foods and probiotics into your diet and lifestyle. So this is a quick overview of current state of research. There's a lot out there, and so I've included at the bottom of this slide 2 links, so 2 papers that I really like: Marco ML in 2017 and Pezzoli 2020. And specifically in the Marco ML, that if you open it up, click the link at the end of the presentation, table 2 has a bunch of evidence-based clinical trials that show what fermented food and what health benefit were found from that research. So if you want more information, I highly recommend going there. So overall, consumption of fermented dairy foods like yogurt or kefir have been associated with weight maintenance. So, if you're trying to lose weight and you have lost weight, incorporating these dairy products into your diet can help maintain it. Long-term studies have showed reductions in the risk for cardiovascular disease, type 2 diabetes, and the overall mortality when you eat frequent yogurt consumption. And research shows that kimchi consumption has anti-diabetic and anti-obesity benefits. And then the consumption of fermented food consumption can also have been shown to alter the mood and brain activity. And that kind of references the gut-brain axis and how the health of our intestine and our gut microbiome can communicate to our brain and our brain health. And like I said, if you want more information, those 2 links are really great places to start. So the current research on probiotic effects usually focuses on disease models. So you'll see a lot of research out there that are called randomized controlled double-blind placebo human clinical trials, which mean that, you have 2 groups. One group will get a bunch of milk, and then the other group will get a bunch of milk with, say, lactobacillus casei added to it. So both groups will drink it, not knowing which one they have. And the researchers and the consumers are blind to which one they're consuming. And then they'll do subsequent, tests on their serum blood, on their microbiota, et cetera, and just to see the results of, does lactobacillus casei in milk have an effect versus when you have milk without it. So that's the gold standard when you're looking at probiotic studies and whether or not they're legit. And a lot of research currently are animal-based research. So again, remember that animal, even though it looks really like you want to say, oh yeah, it worked in this mice, or it worked in like monkeys or on a cell petri dish, that does not mean that it also works the same in humans. The humans are very complex species, and as are humans, and as are animals, and we're both very, very different. So just be aware as well when you see a lot of probiotics will be like, it's been proved, and then you will go to the research and it's been proved in a petri dish. So you don't really know if it works for humans. Probiotics may definitely, so these are 2 studies I'm about to bring up that are cited and been shown to be true. So probiotics may be effective for maintaining clinical remission in patients with ulcerative colitis, especially those who belong to cluster 1 on the fecal bacterial analysis. And that is the link to that research article. And the administration of probiotics, bifidobacteria 536, along with their standard treatment, improved clinical symptoms in patients with mild to moderate ulcerative colitis. And I know probably a lot of people listening to this probably don't have ulcerative colitis, but some people do. And the way that probiotic research and all clinical research goes is they start at a disease model, not so much a healthy person. So right now, the current state of research is people with GI diseases like ulcerative colitis or Crohn's. So that's why you'll see a lot of research proving this first. And then we'll probably in the future get up to healthier models. So this is a slide based on my current research or my past research project that just wrapped up, which is very relevant. The paper has been published and the link is at the bottom, and it's titled "The Assessment of Commercial Companion Animal Kefir Products for Label Accuracy of Microbial Composition and Quantity." So basically what we did is we took 5 human products and 5 animal products, and we compared them. We basically plated them on Petri dishes under the right conditions to see how many bacteria were alive at point of opening after they've been shaken and stored correctly. And then we sequenced the DNA in each product to see what species of bacteria existed in each product and whether or not those species that were in there matched the label. So, if you read the back of it, it says there's 5 bacterial species in it, and then we'll do the sequencing and then we'll find, maybe 4 of them were in there with like 7 additional species that the company didn't even realize or didn't say. So we did the sequencing and then we retested the bacterial cultures 14 days later to see if by their expiration, is everything dead? Is everything alive? Is it increasing and decreasing? And then we kind of assessed the accuracy overall for each product, for their label claims and for their CFU per gram. And so the takeaways from this research were that commercial probiotic label claims, which include the amount of viable bacteria and the bacterial taxa, is not a guarantee. It's not regulated, so what you're reading might not be accurate. And based on our research, probiotics marketed for pets were especially not accurate. And we've also seen research that shows that homemade products have been shown to have more live bacteria and more diverse bacterial contents than commercially sold products. And so if you make kefir at home, you're likely going to have a different bacterial diversity than if you were to buy it at the store. And the reason for this is because the FDA doesn't regulate what companies can claim on their products. And this is specifically for fermented foods. But the FDA does regulate health claims that the companies can make. So the companies can't say that kefir will lower your blood pressure, but they can claim that it will contain X, Y, and Z bacterial species. And ultimately, what this research showed me is that we need a lot more randomized double-blind human control trials to prove a lot of these health claims that companies are making. So a lot of it's not proven yet, and a lot of it they'll still tell you is true. But when you go back to the research and literature, it has not been investigated that much yet. So now we're going to talk about how to break down a probiotic label. So if you go to the store, you see something like a yogurt, how do I read it? So first you want to look for the ingredients and allergens, the genus, species, and strain of the probiotic. The colony forming units usually would be like 10 billion species, or like this has like 1 billion species. So that's basically what it's talking about. The claims are recommended ways to use it, how to store it in the fridge, if not in the fridge, how much you should take per day, and then when it expires. And so I found this really great graphic that kind of translates. So sorry. So we have, this is how dogs are classified. So you have the kingdom, the phylum, the class, the order, the family, the genus, and then the species. So a lot of the times we all have genus Canis, and then we'll have different specific breeds of that dog. And that is the same way that probiotics are categorized. So you'll have, for example, you have Canis lupus breeds at the bottom. So bacteria is the same way. You have the genus, which can be lactobacillus or bifidobacterium. Then you'll have the species, which will be acidophilus or longum, and then you have the specific strain. So it would be Lactobacillus acidophilus NCFM or Bifidobacterium longum 536. And so that is what you'll see on the ingredients, and that's basically what you're reading. So you're just reading what the genus is, what the species, and the strain. And the strain is really what comes down to proprietary blends, or, you know, if a company wants to, or a research study in specific, most clinical studies will have one strain, and that's what the research is based off of. So you want to be very careful when you're looking at that. And here are a couple examples. So one of my favorites to eat is Chobani Greek yogurt, and this is what the label will look like. And then we want to zoom in on the 5 active and live cultures. So they say there's Streptococcus thermophilus, Lactobacillus bulgaricus, Lactobacillus acidophilus, bifidus, and Lactobacillus casei. So you'll see the genus and the species, and in this particular case, they do not have the strain. This is a supplement or a clinical probiotic that you could take. So this is what the label will look like, and this is the part you want to focus on. And so we can see it has a proprietary blend. So, you know, they have patented this blend, and you have the amount per serving. So every time you have a capsule, ideally you're having 40 billion colony forming units. And you'll see right above that, the percent daily value is not determined because, like I said, there's not enough research in this area to even make a percent daily value. Everyone's different, and every strain has a different effect. This one has those like 4 bacteria, and then we have 2 different prebiotics. And then you'll also see the strain right across. So that is if you want to, you know, backtrack and see what specific strain is in this probiotic, that's how you would look it up. And then the last one is GTS ginger ale kombucha, which is one of the most popular kombucha brands you'll see at the store. There we go. We want to see what specific probiotics are in it. So we have Bacillus coagulans, and then the strain, and we see there's 1 billion live organisms, Streptococcus boulardii, and then we have additional polyphenols, glucuronic acid, and then other acids that have been added to the drink. So if you're curious, you know, these are how to read the probiotics. Hope this is interesting. Okay, moving on. So now we're going to talk about what fermented foods can you make at home. And luckily you're talking to a resident expert who was really busy over quarantine. So these are some projects that I've worked on, and I feel comfortable at least giving advice on how to do it. So I've made a lot of kombucha, a lot of soy sauce, honey fermentations, which are really fun, fermented hot sauce, which is delicious. We'll talk more about it, and then fermented pickles as well. And we'll talk about these pictures in detail. So first we'll talk about kombucha. This is really popular, really easy to make fermented food. Takes about 10 to 14 days, and you're gonna need a SCOBY. SCOBY stands for symbiotic culture of bacteria and yeast. And just as a disclosure, I looked it up before today, there are no human clinical studies to date to prove whether or not kombucha is good for you, whether it has bad for you, like any effects. Nothing has been researched yet. So be careful when you see claims on different bottles. You're gonna need a SCOBY, black tea, sugar, and water. I usually use a gallon sterile glass jar, and then some kind of light cloth to cover the top with a rubber band. And then if you want to do a second fermentation, you're going to need fruit for that process. And what you'll usually see in kombucha are acetic acid bacteria and also yeast. So if you remember the beginning of the presentation, 2 big forms of fermentation are ethanol fermentation and lactic acid fermentation. And acetic acid fermentation is a whole nother process, which I didn't go into detail, but as terms of our resident microbes, so kinds of bacteria that live in our body normally, usually it's Streptococcus or Lactobacillus. And if you want to go back to that slide after, you'll see a whole bunch of those resident bacteria. But unfortunately, acetic acid bacteria are not native to our bodies. So when you consume a drink like kombucha, you're consuming the acetobacteria, which, they're not bad for you, but they also will not stay. They will come in, they'll realize they're overpowered by all the lactic acid bacteria and everyone else, and there's a form of competition. There's only so much space, right? So usually the acetic acid bacteria will come and they will go. So it's not really expected also that kombucha will have a long-standing effect like other fermented dairy products would. And then you also see yeast. And one common yeast, which some people might recognize, is Brettanomyces. And Brettanomyces is also the yeast that's used for sour beer fermentation. So sometimes if people like kombucha, it's a really easy convert to get them to like sour beer or vice versa. And this is a book I have, which I really enjoy. I've had it for a couple of years, and there has some really great recipes, how to check if your SCOBY is healthy, if, it smells right, lots of different combinations and recipes. And also that includes some alternative ways to use a SCOBY. I know that some people can use it for a sourdough starter. You can make it like literally a cover for a Tupperware or something. There's a bunch of stuff that if you're willing to go down, that book will show you how to do it. The next one that I've worked on is Korean soy sauce. And this is different than your traditional soy sauce, which includes wheat. This is a process that is gluten-free, so it does not include any kind of wheat or rye. You're gonna need soybeans, salt, charcoal, just to weigh it down. I use dried chili peppers, and then 1 gallon of a sterile glass jar. And then of course you might need a cloth to cover it with a rubber band. And when you do the soy sauce, you also want to keep it stored in a dark but not too cold location. And if you go back to this presentation at the end, you can actually click on the blue Korean soy sauce 5+ months, and that'll take you to a YouTube link that I use to make my own soy sauce. So I can attest that it works. And some common suspects you'll find in soy sauce are fungus and mold. And commonly you'll see Aspergillus oryzae or Aspergillus sojai. And those are a type of mold or fungus. And that's what you actually see on the top on these bottom pictures, the white mold growing. I was really excited to see it because it means that, things are going well. But that's exactly what's forming on top. And those form from soybeans. You'll see a lot of lactic acid bacteria, especially Pediococcus haplophilus. That'll be inside of it, kind of fermenting away. And then, of course, you'll see some yeast as well in the soy sauce. And you'll see Saccharomyces strains and other types of yeast as well. And then if you want more information on the process of soy sauce, what compounds make different flavor combinations and the history of it and more scientific information, this is a great review at the bottom, Diaz-Simon et al. 2020. And if you go back to this presentation, click the link, it'll take you right to that review paper. So I found that was really helpful too. So next we're going to talk about honey ferments. So you can do a lot of things with honey fermentations. It can take up to 3 weeks, and you can keep them in your cabinet safely for up to years if you'd like. You need raw honey, so not pasteurized honey. You want the bacteria in there. And you can ferment garlic, ginger, mangoes, chili peppers, pomegranate seeds. Honestly, the options are endless. You can go on the internet or go on Instagram and see what other people are doing for great ideas. And you're also going to need a sterile glass jar with an airtight lid. As you can see in this picture, I love to save my spaghetti sauce jars or like literally any glass jar I get from the store for olives or anything else. I just hang on to those and clean them really well. And those can be used for this process. And with these kinds of fermentations, you'll see a lot of natural yeasts. So when you get garlic or ginger or mangoes from the store, maybe not mangoes, but there's yeast that exists in the air all around us. So when you buy garlic or ginger, the skins on the outside of those products have natural yeast already on them. So when you add that garlic, for example, to the honey, the natural yeast will start to eat up the sugars in the honey, which kind of jumpstarts that fermentation process. You'll also see a lot of bifidobacteria, potentially in honey or in the garlic. And bifidobacteria is a very native residential bacteria to their gut microbiome, so they'll be most welcome. And also with lactobacillus, you'll see that as well in this fermentation process. And I just added some fun facts about honey. It's pretty sweet. It has antioxidant properties, antimicrobial properties, anti-inflammatory, anti-proliferative, anti-cancer, and anti-metastatic properties. And if you're more interested in honey, this bright yellow link at the bottom is a great review paper on clinical research of that honey has been investigated with. And when you're doing this process, be sure that the honey completely covers the garlic. If there's any, honey touching the air, that is space for mold to grow, and you do not want mold growing. That will ruin it. And I know that botulism is a concern with fermenting garlic. And just to clarify here, it's a concern if you're fermenting garlic and olive oil and not so much honey. So if you do want to do this, make some garlic tasting olive oil, feel free, but just make sure you do your research and you're very careful about the conditions you do. And I love to use my honey ferments in tea. I'll drizzle garlic fermented honey on little pizza crust, or add the ginger fermented honey to my tea. It's really good. So tried lots of options for how to use it. The next one is fermented hot sauce, which is one I've started making over quarantine now that my garden has grown. It takes about 7 to 14 days of fermentation. You're gonna need fresh peppers. I use cayenne peppers, but you can use, sweet bell peppers, habanero, jalapenos, whatever you like. I also add garlic and onions to mine. If you wanna make a sweeter hot sauce, you can try to ferment some pineapple as well. You're gonna need salt for the brine. So you're gonna need, usually I do 1 teaspoon to 1 cup of water, and you're also gonna need a food processor. And again, if you click on the blue fermented hot sauce at the end of the presentation, you'll see a YouTube video to this that I used. And then if you click on salt, you'll find a link to proper brining ratios. So depending on how much you have in the jar, that will tell you how much water and salt you need to add to that brine. And in this product, you'll see a lot of natural yeast that exists on the outside of the peppers, on the outside of the garlic. And I also see lactobacillus and then lactic acid bacteria as well. And when you do this fermentation, you'll know it's ready when you see bubbles racing to the top after around 7 days. You just have to tap the jar and you'll see them. The water will also get a little cloudy, and that's okay. And then you want to make sure the water completely you want to make sure everything in the jar, like the peppers, garlic, onions, they're all submerged under the water. So one way to do this is you can take a Ziploc baggie, fill it with water, and just kind of put that on top of the jar so that it weighs down all the contents and keeps it under the water, but in a safe and sterile way. If you want more information on that, feel free to email me. I'll be happy to help out. And then the last one, which is my favorite, is the lacto-fermented pickles. And it takes about 2 weeks to make them, but they can stay in the fridge for a couple years if you really want to. You can use fresh pickles, and you want to make sure you get that natural yeast from the outside in the pickles. Salt and sugar are used in the process. Vinegar, and then chili peppers, garlic, dill. I mean, you can add whatever you like, and obviously you can also add pickling spices or garlic or mustard seeds. And for more information on this, you can find some recipes online, and the salt and sugar, that's another one for the brining ratios. And when you make these pickles, you'll make lactobacillus and lactic acid bacteria. And you want to make sure you have jars that are the right size and that they're sterilized. So you might have to boil them first, just so that you don't have, bad bacteria cultivating as you wait for them to be ready. Like I said, the water brine must cover all contents, and carefully measure your salt, because you don't want it to be too acidic and you don't want it to be too basic. You want to be just right. So make sure you do enough research before starting. And these are just a couple tips. So if you want to start fermenting your own stuff, it's really helpful to have a cheesecloth or muslin cloth, rubber bands, really cheap pH strips, just to make sure, your acidity is in a safe, healthy level. A food scale, so to measure in grams, or to weigh out, how heavy your jar is, and then how much content you're adding to the jar after. That's been really helpful for me. And like I said, glass jars with lids. So spaghetti sauce containers, yogurt containers, whatever you got, just make sure they're clean. And when you do this, keep in mind to do your research first. So check out a couple recipes online, or check out a book or YouTube videos. Make sure everything is clean. And when you're cleaning things, don't use antimicrobial soap, because that will kill, microbes you might add to the fermentation after, but just use regular dishwashing soap. You'll be fine. It is a process of trial and error, so you probably won't have success in the beginning or right away, but that's okay. You have to have, a little bit of endurance and perseverance. It'll work. You just have to try a couple times. And there's always going to be lots of manipulation points. So for kombucha, for example, you can use, I recommend black tea, but you can try later on black tea, half green tea, different kinds of sugars. Like I said, with the hot sauce, you can try pineapple, garlic, carrots even. You can, you have lots of places you can experiment. There's lots of Facebook groups out there for fermentation and help with fermentation. So I recommend joining a community for help, or, maybe if you want to talk to some more people about it. And like I said, there's lots of YouTube videos and accounts that you can also look into that have great resources. So we reached the end of the presentation. Thank you so much for your patience and for, listening to all this content. I know it's a lot of information. If you want more information about fermentation, probiotics, prebiotics, it's spelled wrong, you can go to ISAP, which is the Scientific Association for Probiotics and Prebiotics. It has information at the consumer level, at the scientist level, and also at the clinician level, so everyone can, benefit. And they have some really great, easy to understand graphics. And these are some links in case you're interested. Later on, at the bottom, this is my sourdough, one of my sourdoughs, and then of course this is my current SCOBY. It's pretty thick. And this is a QR code for the end of it. If you want to scan that, you can get a survey. And then next week or 2 weeks from now, we're going to have a talk on Block the Bite, a guide to commonly encouraged ticks and how to protect yourself and your family. So with that, yeah, go ahead, Kristen.
Great job, Breanna. That was a really great presentation. And like you were saying, there is a lot of trial and error, but it is a lot of fun to ferment foods, and the opportunities and options are really endless.
Yeah.
So like you were saying, there is an evaluation, and I just put the link to that in the chat box. So before you hop off, please take a few minutes to go to that eval and fill out a few questions for us. That'd be extremely helpful. And we do have a few questions. It looks like we have enough time to cover them. So I'll go ahead and read those off for you.
Yeah.
The first question is, how long does it take for your gut bacteria to recover from taking an antibiotic? And how can you improve the recovery process?
So it hasn't really been investigated specifically how long it takes to rebound. I would say probably around 1 to 2 weeks. That's after consuming consistent probiotics. After the run of antibiotics, you can probably expect to have your gut microbiome recover. It's a very flexible organ, so it doesn't take very long for it to change. It could be different 1 week to the next week, depending on your diet. So yeah, I would just recommend definitely having a lot of probiotics in your diet, or probiotic containing food in your diet after you have that.
Next question is, what is the most effective means to deliver live probiotics?
I would definitely recommend having refrigerated probiotic fermented foods. So things that, are not shelf stable, things that have active bubbles, that's really helpful too. Yeah, that's probably the best recommendation.
Okay, and that kind of relates to the next question, which is, how do probiotic supplements survive the acidic conditions of the stomach?
There's a lot that have something called an enteric coating on the outside of the supplement, and that enteric coating is specifically designed to withstand the acidity of the stomach, so that it will kind of, travel through the stomach untouched and get to the intestine. And that's something that you really need to look for on the label on the front. Usually they'll say if it is or not. So if it doesn't say that, it likely is not. And with a lot of vitamins too, they do not have enteric coating. So, you have to be careful with what you buy. Those might not reach the intestine as in such an effective dose.
Okay, that's a really good tip.
Yeah.
Next one is, which concoction, starter or prepared food offers the greatest diversity of probiotic strains?
So that's something that is still being researched right now. Based on clinical studies, I would stick to dairy-based probiotics like kefir or yogurt, just because they have the highest amount of lactic acid bacteria, which have been shown to have anti-inflammatory properties. And, the research is still pretty new, like I was saying, but if I had to recommend it, I would definitely stick to the dairy probiotics just because of the amount of research out there right now.
Okay. and I'm just going back through the chat box a little bit because a few have come in since we started this, but for pickles, how long do you let it ferment out on the counter before putting it in the fridge? And do you have any tips or tricks to offer?
Yeah, so with pickles, I usually will put them in the fridge right after I finish the jar. And so that way, anything that isn't supposed to be in there won't be growing at room temperature. And usually I'll keep it in the fridge for 2 weeks before I dare to open and try it. Yeah.
Okay. And let's say you have an overabundance of sauerkraut. Can you freeze the sauerkraut and maintain the probiotics?
It depends. I'm not sure about the specifics of sauerkraut, but I can speak to kefir, which, they're similar enough. When you freeze kefir or other fermented foods, a lot of the times you're going to be killing the bacteria, like the live cultures. So I don't know if freezing sauerkraut will preserve the bacteria. Some people will like dehydrate the actual like lettuce and cabbage itself and then rehydrate it to bring the bacteria back alive. But I'm not so sure about freezing it as a whole. So sorry, I'm not totally sure about that.
Okay. Another question that just came in is, how do you make your own SCOBY?
So if you really want to make your own, you can buy a jar, like a bottle of kombucha from the store, drink majority of it, leave like 1/4 cup in the jar and just leave that bottle on your shelf for like a week or two. And it will actually naturally form a tiny little SCOBY just from being out and about. You can also order it off Amazon for a couple bucks, or you can, ask a neighbor or friends if they have any extras as well. But yeah, if you just leave out your jar for a little bit safely, it should form a SCOBY.
All right. And I have seen that myself, so I know that's true. And is water kefir equal to dairy kefir? That's the last question I see.
Yeah, so kefir is made through the process of like kefir grains. So the grains can be fermented in water and they can be fermented in dairy. So but the whole process of fermentation is like the yeast converting sugars into these other compounds. So I don't know if water kefir will have as much of those sugar carbohydrates than the dairy products will. So I cannot speak to water kefir. I'm assuming it's similar just because they're both like fermented with the kefir grains, but just due to the sources of carbohydrate that's available in dairy, I wouldn't say they're equal. I would say they're different, if at all.
Okay. Yeah, they're both very tasty. The water version, you can do a second ferment with that as well, if you like the bubbly taste. So I think that's it for questions. Just want to thank everybody for joining us today. And we hope to see you next week for our topic on November 4th, which again is Block the Bite, a guide to commonly encountered ticks and how to protect you and your family.